one has not been banged on and it works.
It just came to tune.
This one has two different tones. And let's all listen to Dennis.
Okay, I have absolutely no idea whatsoever why some of these rocks ring and some of them don't. They look about all the same. I have a suspicion that it has to do with the fracture pattern in the rocks. Some of the fracture patterns may tend to muffle the sound, others may tend to make it a little bit louder. The rock itself looks like a pyroxenite. Supposedly it's a diabase. It may vary from place to place, but as I looked at one nice fresh chip, it looked as though it was mostly pyroxene. Pyroxenite is a metamorphic rock that starts out as an igneous rock like basalt and then gets metamorphosed at fairly high temperature and pressure, so that pyroxene would be the main constituent. The difference between pyroxenite and diabase, by the way, is that diabase has a fairly high content of plagioclase feldspar, which I do not see here. Now, it may be that if I had a thin section, I could look at it more closely and with special equipment, I could see a little bit better. But as it is, my field identification would be a pyroxenite. And to go back to the sound, I haven't the least idea. It would be an interesting subject for someone to experiment with. It would be possible to break these rocks into shapes that were predetermined and to see which shapes and which rocks gave you the better sounds. Some of these, the sound dies out immediately, it's very muffled. In some of them, the sound lasts. The vibration of the rock persists for a fair length of time. Again, why? Damned if I know. Yes, that's very good.
That's a couple of them.
Good, good.
That's the next one.
Yep, got the lichens in it too.
And this is John.
Yeah, this is a nice little piece of geology right here.
Yeah. This is real good with it. Well, here we go, Rupert.
Again, Dennis Coskren, the geologist at Montgomery College, still here at Ringing Rock County Park in Bucks County, Pennsylvania. Earlier, I was looking at the rocks upstairs. Those rocks are the ones that you hit and ring with the hammer, and they're a good, hard, igneous rock. Here, this rock is completely different. It's a sedimentary rock, fine-grained sandstone and siltstone and shale. On top of this waterfall, the waterfall's over there, is the igneous rock. It's nice and hard. It's a very hard rock. So the water comes over that hard rock, and when it hits the softer rock underneath it, it immediately erodes it away and drops down, making this nice, pretty waterfall. Now, the valley itself is of very great interest in large-scale geology, because similar valleys are found all up and down the east coast of North America, all the way from the Bay of Fundy between Nova Scotia and Maine, down through the Connecticut Valley, Gettysburg, down through the valley over in Seneca in Montgomery County, which I'm quite familiar with, all the way down to Florida and Georgia, where it's present only in the subsurface. You don't get to put a hammer on it. I didn't know there was one here, but I can see it. I know it is now. The rock itself was deposited in the valley because when the crust was pulled apart about 180 million years ago, it drops down, and any place that drops down is immediately a place where you trap sediment. And so the sediment immediately came to start to fill it in. Now, anytime you pull the crust apart, you lower the pressure on the stuff deep down underneath, and when you lower the pressure, you lower the melting point, some of it melts and comes up to the surface as basalt. And the rock on top here has the composition of basalt. However, it's a very, very thick unit of igneous rock, and it is thick enough so that it crystallizes very slowly and is coarse-grained. So it's no longer called basalt, but it is the same material. And that's what makes the ringing rocks above. You can see pieces of it up on top of the falls, because that's what's making the rim of the falls very hard and keeping it there, keeping it from wearing down. Okay, these rocks here are the siltstone and sandstone and shale. The thin layer, each of these layers is probably an individual flood. And these thick beds are the coarser material, silt and fine-grained sand, and the interlayers in between are the softer rock that was laid down as mud when you didn't have a nice big flood here. And so each layer here is one flood. It's fairly even layers, so this was probably deposited in a flood plain. The water was not really flowing very fast right here. If you looked at it in another place in this valley, you'd probably find places that were coarse sandstone with nice cross bedding, and that would be where the river itself was flowing down the valley fairly swiftly. But here, this was quiet water. This was all backwater stuff, because there isn't any cross bedding. You can't see any current features here. Yeah, here's a good chunk of the rock itself. Yeah, this has actually been cooked a little bit. It really is not truly a sedimentary rock anymore. It's a metamorphic rock that has been cooked by contact with the igneous rocks at the top. You can imagine we're about 15 feet here below the igneous rock up at the lip. And if you spend a few hundred or 1,000 years sitting underneath a lava flow, you get cooked. Not cooked to a very high degree, because it's not right up next to the rock, but it was cooked. And so it's now actually been recrystallized by heat. So it's a contact metamorphism. But you can see the layers in the rock here. They're still preserved. Now the material on the surface here would be lichens mainly. And lichens are symbiotic combinations of a fungus and an alga. Neither of them can live separately on the rock, but together they can make a living. I don't know which lichen it is. Lichen taxonomy is absolutely miserable, especially since the lichens are made up of two separate organisms, and some lichens have a choice as to what the algae might be. You might have one algae in one version and a different algae in another, and some of them even contain some bacteria, blue-green algae, as well, meaning that they're combinations of not only three separate organisms, but three separate kingdoms. The kingdom of the fungi, the kingdom of the plants, and the kingdom of the bacteria.